Hello everyone, this is Samir Das Gupta and I'm here to present the peer grid assignment for my recent course on machine learning foundation for product managers. In this project, we will build a model to predict the electrical energy output of a combined cycle power plant which uses a combination of gas turbines, steam turbines and heat recovery steam generators to generate power. As a part of the assignment, hourly average ambient environment readiness data is provided gathered from sensors at the power plant, which will be used in our model. As part of the assignment, we will have to determine what type of machine learning approach is needed and select an appropriate output metric to evaluate performance. Also determine which possible feature we may want to use in the model and identify different algorithms we might consider. Determine a validation strategy for comparing different models and use the validation approach to compare at least two different models and select the model with the best performance on validation set for final model. Finally, evaluate the performance of the final model. First, let's investigate the dataset which is provided. The dataset has five variables: temperature, ambient pressure, relative humidity, and exhaust vacuum being input, and net hourly electrical energy output being the target. For each variable, range is provided as mentioned in the slide. For this assignment, I am going to use Excel-based calculations and analysis for completion. I have used some quick Excel formulas to for initial data understanding. If you look into the analysis results, one can say all variables are continuous variables. Input variables AP and RH, that is ambient pressure and relative humidity, have a positive correlation with the output variable P. Similarly, input variables AT and V, that is ambient temperature and uh, exhaust vacuum, have positive correlation with output variable PE. For data preparation, I have split the data including 9,568 rows into three parts: the training data, which is 70% of the entire set, kept 10% for the validation set and 20% for testing at the end. For this assignment, I'm going to use linear regression and multiple linear regression approach and use mean square error to evaluate performance in accomplishing the task. Let's first determine which feature or variable we should use in this model. For this first step, I have performed linear regression for each of the feature versus the output. Here are the results from the linear regression performed for each input. Uh, if you see, uh, and firstly we have considered the R square values for each. If you see the R square value for ambient temperature T and the exhaust vacuum V is completely much better than the ambient temperature for AP and RH. So while thinking of a model, initially we thought that a combination of T and V should should be a good model to determine the PE. However, as a model too, we have also considered AP and RH as well, along with T and V, and we also consider a combination of all four as a model. So in total, we have considered four models here. First one, as I mentioned, is a combination of T and V versus P. That is ambient temperature and exhaust vacuum versus a PE. The second one, a combination of T, V and AP. Third one, a combination of T, V, RH and RH versus P. And fourth one, a combination of all four variants or variables to measure target. If I compare the adjusted R square or the standard error, I could very well see that in comparison to the first three models, in model 4, the values are much better. and the standard error is comparatively lesser than all the three, and the adjusted R square is more. So this gives an indication that probably it is a better model in comparison to the other three to determine the PE value. And so what we have done, since we have secured a validation set for this assignment, we have used the same models to on the validation set as well to check if the assumption is correct or not. This now this is done on 10% of the sample data provided to us, and the same four models are used to check if the model that we have considered in the previous phase is also considered as a part of validation or not. Now, if again we compare all the four models, we see the standard error for model 4 is better in comparison to the other three, as well as the adjusted R squares. So this proves that our consideration of model 4, that is a combination of ambient temperature, exhaust vacuum, pressure, and relative humidity, would be the ideal case or ideal model to determine the PE value for this project. Now we have used this model. We have again performed the regression analysis using this model for the test data provided, and these are the results, where we see that the standard error is pretty good. And if we go back to the in comparison to the other models, as well as the adjusted R squares, and for each of the variables or features provided, we see what are the coefficients and what is the intercept value which comes. So as a whole, I can say that in my analysis, the concluding statement can be my output will be best predicted if I consider all the feature in the model. The coefficient would be best in this case. Here I rest my submission of the assignment. Thank you, everybody. Have a good day. Bye-bye.